right, today I have Dr. Fraley here, the analytical chemist of the department, to help explain how light interacts with different molecules.
Glad to be here today. There are 7 types of electromagnetic radiation. Let's see how each interacts with matter. The lowest energy by far is radio. Let's say that this is a nucleus of an atom. Radio is so weak, all it can do is just rotate the nucleus around. That's all. Maybe some of you have experienced that, not just listening to the radio, but if you've been to the hospital and had an MRI done of your body, the nuclei of water, the hydrogens in the water, rotate around, giving very good information. Let's go to a little bit longer wavelength, and that turns out to be microwaves. You've got a microwave oven at home. How does that work? Well, let's try this. I'm going to make some water. So let's put some tape on here. Oxygen in the center. And we'll take 2 hydrogens. Okay? Water is a bent molecule, H2O. The way a microwave works is it spins the molecule. The whole molecule spins. By spinning, the whole molecule generates heat when they bang into each other. As water spins, it gets hot, producing the heat to heat up your frozen pizza, for example. Should I sing the song? Yeah, okay, we'll pass on the Mickey Mouse song for right now. Okay, let's go to the next one. The next type of radiation is infrared. Infrared radiation causes molecules to stretch and bend. So this is carbon. Actually, chemists always think of carbon as being black, hydrogen is white, and oxygens as red. They're not, but at least it helps us think like that. Okay. So, carbon dioxide is a linear molecule. 2 oxygens, 1 carbon, CO2. Now, when you shine infrared, it is more energetic and can cause stretching and bending. Here's stretch. This is symmetric. This is asymmetric. And we can have bending like this. That's like scissoring, isn't it? Like a scissor action. And the whole thing can rotate like this. Which is lower energy? Doing this, you weightlifters, or picking up something. This takes a lot more energy to do this. So this is for carbon dioxide. And we'll look a little bit more about this in just a few minutes. Let's go to visible. Visible light has shorter wavelengths, and it goes in the order that you've known since elementary school of Roy G. Biv. Red, orange, yellow, green, blue, indigo, and violet. They had to have a vowel, that's why they have indigo. That interacts with the retina of your eye. Now, let's go to the next thing. What was the last one I said? Violet. So, beyond visible is ultraviolet. Now, when we get to ultraviolet, things get to be much more energetic. The wavelengths are much shorter. You can have a bond, shine UV light on it, break bonds. That's why when you're outside in the sun and the UV light from the sun hits your skin, the melatonin in your skin cells say, ouch, and the melatonin turns darker and you get a suntan. Let's go beyond that. The next one is X-rays. Are so energetic when bang, they flat out knock out an electron in an atom, making a positive ion. That's why when you're at the dentist and you get an X-ray of your teeth, what does the dental hygienist do? They cover you with a lead apron to protect you. And finally, let's go to gamma rays. Shortest wavelength, highest frequency, greatest energy. Here's a good example of the use of Gamma rays. Ben Whorf was a graduate of Georgetown College in the early 1980s. Went to Harvard Medical School. Ben was one of the earlier developers and practitioners of something called a gamma ray knife. Got a tumor in your head, cancerous tumor, can't operate. They put a helmet on your head with certain holes, and they can shine the gamma radiation this way, this way, this way, and they all intersect at one location to try to knock out the tumor. That is a list of the 7 types of electromagnetic radiation. They all go at the same speed, the speed of light, 186,000 miles a second. They all go through space in a sine wave, but the wavelengths could be very long, like radio, or very short, like gamma rays.